Good day, friends. Welcome to my channel lecture series on power electronics. In this lecture, we will discuss about three-phase half-wave controlled rectifiers. Three-phase controlled rectifiers have the advantages of reduced ripple content in the output voltage, and it can be used for high power applications. The different types of three-phase controlled rectifiers are 3-pulse converters, which are the half-wave controlled rectifiers. 6-pulse converters and 12-pulse converters are all full-wave controlled rectifiers. When we mean controlled rectifiers, the semiconductor device used is a thyristor, that is an SCR, instead of a diode. Rectifiers which convert AC to DC find applications in many areas like DC motor speed control, DC supply for inverters, electrochemical processes, DC traction, and high voltage DC transmission. In the case of a single phase half wave controlled rectifier, a single thyristor is used and a single phase supply is given. The input voltage waveform is shown over here. The output of a single phase half wave controlled rectifier will be a pulse, a single pulse for a duration of 0 to 180 degrees, and during the negative half cycle there will not be any output. If the firing angle is changed, a part of the positive half cycle will be available as the output. In the case of a three-phase half-wave controlled rectifier, three thyristors are used, T1, T2, T3. Each thyristor is connected to one phase of the three-phase supply. Let us now see the operation of the three-phase half-wave controlled rectifier. T1 is connected to R phase, T2 is connected to Y phase, T3 is connected to B phase. The waveform of T1, the voltage waveform of T1 is shown by the red color. The voltage waveform of T2 is given by yellow. T3 is given by blue color. If we observe the input voltage waveform, the thyristor T1 has a positive voltage from 0 to 180 degrees, and from 180 degrees to 360 degrees it is having the negative half cycle. So when the triggering pulse is given to T1, it would start conducting. If the firing pulse is given anywhere between 0 and 180 degrees, the thyristor T1 would conduct, but the thyristor is getting the maximum positive voltage from this point, that is omega t is equal to 30 to omega t is equal to 150 degrees only. Between 0 and 30 degrees and between 150 and 180 degrees, though it has a positive voltage, it will not conduct when the triggering pulse is given. This is because the other two phase thyristors are connected in such a way that they get the negative voltage, and because of that the highest positive voltage for the R phase thyristor is not available. Hence, the thyristor will be conducting from omega t is equal to 30 to 1 omega t is equal to 150 degrees when the firing pulse is given. Similarly, T2 would conduct from 150 to 270 degrees where it gets the highest positive voltage, and T3 would conduct from 270 to 390 degrees where it gets the highest positive voltage. So if the firing pulse is given at the instant where the highest positive voltage is available, we would get three pulses as shown here. So the output voltage of a three-phase half-wave controlled rectifier gives three pulses, hence it is called as a three-pulse converter also. Three-phase half-wave controlled rectifier for various firing angles is shown in this picture. The input waveform, a three-phase waveform, is shown here, and the output of the three-phase half-wave rectifier for a firing angle 0 is 3 pulses as shown over here, and when the firing angle is less than 30 degrees, we can see that the output voltage waveform shown in the black color is a continuous one. And if the firing angle is greater than 30 degrees, the output waveform is discontinuous and it is going to a zero value at some instance. Let us see the operation of the half wave rectifier for firing angle less than 30 and greater than 30 in the coming slides. When the firing angle is 0 degrees, which corresponds to omega t is equal to 30 degrees, T1 conducts from 30 degrees to 150 degrees, T2 conducts from 150 to 270 degrees, T3 conducts from 270 to 390 degrees. If the firing angle is less than 30 degrees, which means omega t less than 60 degrees, between omega t 30 degrees and 60 degrees, T1 conducts from 30 plus alpha to 150 plus alpha, T2 conducts from 150 plus alpha to 270 plus alpha, T3 conducts from 270 plus alpha to 390 plus alpha. Here we can see that the voltage waveform is continuous. When the firing angle is greater than 30 degrees, the T1 thyristor conducts from 30 plus alpha to 180 degrees where the voltage becomes 0 and T2 conducts from 150 plus alpha to 300 degrees and so on. So when we see the firing angle change, when the firing angle is less than 30 degrees, the output voltage waveform is continuous. When the firing angle is greater than 30 degrees, the output voltage waveform is discontinuous. The average output voltage of a three-phase half-wave control rectifier is given by V0 is equal to 3Vm by 2 pi into cos alpha, where Vm is the maximum value of the line voltage and alpha is the firing angle. The operation of a three-phase half-wave controlled rectifier for various firing angles, say alpha is equal to 0, alpha less than 30 and alpha greater than 30, is explained in this lecture. Thank you.